version of Microsoft, so I have no idea how to get the slides started. Hey, there we are. Yeah, so I think everybody knows I've spent the last 4 or 5 months just playing around with these LNBs as a converter. It's been great fun. And it results in that. This is one I borrowed from Sam. There's very little to them, as you can see. Really a very easy way of getting on 3 centimetres. And I think I'm really pleased with them. And it's definitely worthwhile putting the article in Scatterpoint. And it's worked well enough that at home I use 2 dishes on 3 centimetres. So very easy just to change the receive side over to one of these. So the original idea was just to be a converter with an LNB on the dish. And then everybody who wanted a kit said, oh, I don't want that, we just want a nice little self-contained unit. So there goes out of the game, but they're still quite useful. So I've had that working at home for 2-3 months now, and I can't find any shortcomings really. Same sort of sensitivity as what I had before, so I'm very pleased with it. I'm going to try and rush through because I thought I had a little bit longer than I actually have, and I don't want to be late for John there. So I'm going to rush through. If there's any questions, it would be better if we leave them to the end. So the real advantage is that it's cheap. So I don't deny that. And the great thing about satellite LNBs is if you lose one, it's what if you lost £3 or £4? It really doesn't matter. Yes, that's why I like them. So yes, the weakness. There is a weakness, and that is strong signal handling must be poor. But how many people have that as a problem on 3 centimetres? I've not seen any. Yes, thank you. I've not seen any problems due to that. So just a quick run through of where we are with current satellite LNBs. If it's a single output LNB, they're virtually all like that block diagram. 2 RF amplifiers, switched input amplifier for vertical or horizontal, common amplifier, 20 dB again, through bandpass filter as an image filter, then into a mixer, which used to be pair of Schottky diodes on a half-wave ring. That seems to be going out, and I see a lot of gas FETs at mixers now, but they're passive. You'll notice there's no DC on them, but I'm not going to talk too much about that. 2 local oscillators, I think historically really, because Sky used to have just that one band that was 10950 to 11.7, and then when they got the opportunity to grab a load more, they got that upper band. But the important thing is that they extended the lower end of the lower band down to 10.7 gigs, and that's really useful for us, as you'll see shortly. So, in addition, you've got the RF amplifiers, 30 dB, bit of an underestimate, probably near 35 or 40. And that LNB gives you what? Gives you a good noise figure. I'll put money on that. It will give you by default a first IF of 618 megs, because by default you get the 9.75 gig oscillator running, unless you put a tone on there. It should give you a good image performance as well. Now, I've got an example here of, I don't know what LNB it was, but typical LNB. And if you come down 618 megs on the image side, you'll see you're about 25 dB. But I've measured somewhere between 25 and 40 dB. The only issue is the local oscillator drift, of course. And I know I've talked about that before and said it's amazing how stable a local oscillator can be when it's free running up there, and how good a noise performance you can get, and what sort of a nice tone you have. But nonetheless, you're really going to want some way of taking that drift down. So what is that we can do? It really is quite simple, and that is if you just connect an LNB up, you've got an input signal on 3 centimetres going through. That'll come out at 618, and that's the smaller signal on the right there. But if you put a stable signal source in at the input as well, and you put it on the low side, which you're going to want to do so that you don't get, you want the frequency to go up on the IF as you're tuning up the band. So you'll have to put this signal on the low side. You know that those two, if I expand that graph, you know those two signals are going to drift around as the local oscillator drifts. So far there's nothing really that's helped us. But what you can say is the difference between the two signals always remains the same. It's independent of the local oscillator drift in the first local oscillator in the LNB. So there's a way forward that we can actually work on that in some way to give us a feature where we reduce the effect of the local oscillator. So the obvious thing to do is to put it through the sort of circuit on the right, standard circuit there for demodulating AM, I suppose. You can do that. You could also, I suppose, put so much signal on the input that the LNB starts to clip, or the last IF stage starts to clip. And that will work, but there's one obvious thing about that, and that is because you've no selectivity in the IF strip, then you're going to get no image second. If you treat that stage here as being a second IF, and the second IF is going to be that difference frequency, then you're going to lose out 3 dB on the noise figure, obviously, straight away. And you're going to have another problem as well, and that is that you're going to have harmonics of that reference oscillator coming through. And on this unit here, it's coming through at 600 megs, because the IF output on these are 18 megs. Come on to the reason why that is later. So if you don't put any selectivity in, you know you've got possible spurious responses either side of those signals, as well as the image on that side. So we need selectivity. We can carry on that same idea of using an MMIC or any sort of amplifier to clip and get that to mix. But we've got to put that outside of the LNB. Another disadvantage of just trying to use the LNB itself is because you have to feed DC up the coax to the LNB in its normal use, there's going to be a choke to take off that DC, and because those LNBs are meant to not have any IF below 800 megs, they don't bother putting much inductance in there. So at 18 megs, you're going to lose most of your IF across that inductance. And on that particular LNB, it's the right-hand bit of tracking there. That's quite large compared to some of the LNBs I've seen. So that's another reason why we really can't just use a simple approach of letting the LNB itself clip. So going back to the other example of the limiter and the mixer, the obvious thing we can do is put some filtering at 618 megs and separate filtering for wherever you choose to have the local oscillator coming through, the reference signal coming through. But that's a bit complicated, so I'd much rather bodge things. And do you know, it does that. I've had that happen before. I don't know why, it's just that one picture that does that. So because we're only at 18 megs, second IF on there, what we can do as a really nice bodge is to make sure the 618 meg filter has a nice flat top response so that the local oscillator isn't too far down the slope. So in that example, only about 5 dB down, but I'm still getting about 25 dB image, or I should do, it's not drawn as that. And that's exactly what I've done on all of these. And that seems to work very well. So you might want more image response, I don't know, but that's good enough for me, and it's good enough not to reduce the noise figure down appreciably. So far, the basic converter becomes a signal source to act as the reference coming in. And because one of the big advantages of this is you don't need much local oscillator power, because you're going to use the gain in the LNB to actually boost that signal level up to become the local oscillator. So I know strong signaling isn't going to be very good, but who cares? And what that means is just an ordinary Schottky diode multiplier will still give you about 20 dB more power than you need, and gives you a very easy way of jumping up from, say, 450 megs in this case. You know, anyone who's got an old PMR kit that will give a couple 100 milliwatts or so out, that's enough. And we've already talked about the need for selectivity before the amplifier stage. And I put in about 20 dB of gain there, and that's consistent with about minus 40, minus 50 dBm injection at the probe. So that is one of the big advantages, how little local oscillator level you need. For the purist, I know this is copied straight out the scatter point article. If you're not happy having all that signal going through with the wanted signal, and you think that doesn't help the spurious performance, you could always use a quad or dual LNB and use the separate vertical and horizontal amplifier sections. They're completely separate, so you could put the probe in a vertical plane, null out what signal you get through on the horizontal part of the circuitry, and do it that way. I've never tried that because the simple way seems to work really, really well. So choice of second IF, there is a limit to that, and I would say 150 megs is about the maximum, and it's simply because of the high-pass filter response in all these LNBs. So most of them roll off the IF below about 800 megs. The difference I get in operation here with different LNBs is purely down to where they've actually started to roll off. So in this case, one of the old Cambridge units, you can see we're on this part of the curve here. 18 megs down is still on the flat part, so is 50 megs. I'll just show that for 3 or 4 different IFs. And you can see that you're not losing a lot of that local oscillator power that's down converted until you get up to 70 cents. And you can see you've so much loss there that it's just a waste of time. That's on the IF section. If you look at the filtering on the RF section, well, you still get another 10 dB of loss at 70 cents. So, as I say, 2 meters is really the maximum IF you could use. On the kit, it was interesting when I came to do the multiplier board here. I wanted to find a way of actually getting the diodes on the board and to try and simplify it as much as I could. It's FR4, so I didn't really want any 10 gig signal on the board, and I'll come on to that in a minute. You can see the original boards I tried were just ordinary blank bits of board, just drilled a hole through. Instead of pointing at it, I should do that. And so I just put very light coupling between the on the filtering on this multiplier, because I knew there was going to be loads of signal spare. So, and you'll see later, the spectrum is remarkably clean, given, well, comparative thing, but given that we're multiplying in one step to times 23. That works quite well. But as I said in scatter point, the trouble is when you're trying to... Oh, and you can see what I've done here. I've put the diode straight across the input coax, so I've got my side cutter, snipped away a bit of the outer to get in at the inner, soldered the diode, which is a back-to-back Schottky, and put that straight across here. No matching on the input to it or the output. The biggest trouble is you lose about 4 or 5 diodes onto the carpet before you ever get one soldered down, which is a bit embarrassing. So I thought, if I'm going to do a kit, we did a kit for the Cambridge Club, and a lot of people hadn't even done surface mount, so getting them to solder the Schottky on the bit of coax was not a very good idea. And it was easy enough, just using the plated through hole on the board and pushing, getting the diameter right, and then just pushing a bit of inner of some semi-rigid down that hole, so a bit of an interference fit. You could then solder the diode straight across from the ground to the inner, and then just a bit of wire as a choke. Again, there's so much signal you hardly really need a choke there. One of the reasons for using that approach of the filter and soldering straight in like that was to make sure I didn't get a great deal of hop over. I should have said that at the start. I didn't want a lot of that coming over here, given the high order of multiplication. And that's the spectrum I got this week, which is far better than we've actually measured on some of the units. So I don't pretend that we always get on the 22 and times 24 a signal that's over 60 dB down. So we have seen that as bad as 45, 50 dB. But I think it's a good indication of what you can get if you're careful with the screening and the way you build it. Signals do come back further up. I guess you've got the coupling directly between the probes and it's going to resonate sooner or later. But if you remember that image filter, that response starts to come down at around about this point here. And I actually find if I do a sweep, a spurious sweep, I'm not really getting many spurious components that are greater than 40 dB down, and then it's only one or two. So it does seem to work out. If I measure the output on a lot of LNBs at the IF of what I get for minus 40 dBm at the probe, and if I do this at 10.35 gigs, which suits this 18 meg IF, you can see there's quite a wide range of output. And the Thomson one really does give a lot of output. And the reason for that is that unlike most of the NBs, the high-pass filter effect goes right down to about 200-300 megs. That's the only one I've found that does that. But you can see there's still a good range that gives plenty of output. In fact, on that one, there's so much output, the thing was already clipping, so I had to drop the level down to actually get the 5 dBm. So that's a projected figure, really. You can see from that list that the worst is always a Grundig, and they seem to do the job properly and roll off very quickly from 800 megs. Going back to the mixer and the selectivity that I'm putting before it, originally I just used a couple of coupled lines out of semi-rigid, but for the kit I thought that was going to be a bit too scruffy, and I found that these Toco helicals were pretty much the same sort of performance. So on these kits, that's what I've used. So we're back to the basic converter. I thought a lot of people might want to drive that from whatever they had at 450 megs, but most people just want to build up a 450 meg multiplier to go with it. On this one, we've used 80 megs of the IF because you can really conveniently use a 10 meg TCXO to great advantage. It's very simple, times 3 times 3 times 5 will give you 450 megs. It means you don't have to lock that TCXO. If you want a high standard, you can just plug it straight in. Stop yawning, John. And, and that seems to work quite well. I put that up just for the sake of interest. What I have found is to get the 100 milliwatts, just using a standard sort of medium power MMIC on a SOT89 package is really good. All that resistive feedback seems to make them particularly stable. And you saw on that final times 3 multiplier, there's no matching there. So it's seeing a pretty awful load. I never see any instability at that point, even if I occasionally do down there. So that was a surface mount board on that multiplier. I thought that was easy enough to make. But some people... Oh, we had a build of some of these units last week at Anglesey Abbey. And it was interesting to see how some people were slow and some people were moderately quick. But we had 7 hours there and one chap hadn't got that board finished. So it's really easy to underestimate how long it takes some people to build the units up. So there's another shot of the inside of that unit. Now, another interesting thing was I'd hoped that I would be able to get enough signal on that local oscillator that I could use nice lossy cable, like quarter-inch cable, UR223, something like that, to connect up a local oscillator. And it wouldn't be too bad. In the end, it's worked out really well. Because at one of the rallies, I found some of this Sky twin cable, which is used for the Sky Plus installations. And not expecting anything really good, I thought, well, I'll try putting the 10 gigs down there and see what it does. Absolutely staggered to find the loss is remarkably low. So in this 16 metre length here, I'm only getting 20 dB of loss. And I will switch this on and show it. And that's remarkable, really, because we'll ignore the beacon down there. And you can see, even with 20 dB of loss, you can see it coming to life. Because the reason that it's suddenly coming to life like that is because of the 680 meg filter. There is only that 120 dB stage. So if I switch the converter off without any input there, there's some noise coming through from that MMIC stage. But because of all the gain in the LNB, as soon as that MMIC starts to clip and you start getting conversion gain, then you're getting a lot of signal. So it's very good comfort feeling that you know it's basically working if you're hearing that noise come up. And 16 metres, I don't know, but that should be enough to get from a chimney, even on a... Yeah, exactly. I thought you'd say that. But I mean, I'm in a bungalow, and 10 metres is enough, so presumably 16 metres is enough to get from a chimney on a normal house. So I think that's really a useful feature. Oh, it's interesting, that cable is made up of the screen. There's a longitudinal length of aluminium just folded round, and then an outer screen. And the insulation is it's a very soft material and very aerated as well. You want that down, John? Yeah, sorry. Oh, in terms of stability, I'll just to show it is stable. So I've just got a source down here. So, very stable enough. What I should say is because of all that gain, the actual amount of output's very dependent on how much local oscillator you have. So if you wanted to calibrate an SDR receiver, say, it's not too good for that. But as you hear that level come up, you are hearing a fairly constant signal to noise. So, it's not critical on level in terms of the sensitivity you get. And I should say, I claimed 1 dB, and Sam measured or guessed about 1.5 dB on the unit that he had, which is this one, when you're doing sun noise. Oh, and moon noise with that on a 2.4 metre dish. So there's another indication that's working quite well. And as I say, I made up 25 boards for the Cambridge Club. And we did that last weekend. I think it was a success for those that were there. If anything really comes out of that, it was this issue of surface mount and the difficulty that people have that are not used to that. I don't know what we can do about that. I mean, the surface mount gives you repeatability, doesn't it? I mean, it really is worth sticking with if you can. But we need a way of helping out people doing the building, I think. There's no point in supplying the surface mount as a kit because I think it loses the advantage of someone knowing that they've actually built it in the end. So, right, have I rushed through that too quick? No, I think that's about right. So that's what I've been doing. I'm not sure where to take this next. Doing the complete kit was quite time consuming. So I don't know what the interest is, whether people want to use that. I think it's a damn good club project. So I think it's worth other people having a look at. As I say, when I've used that portable, I've not heard a spurious response yet. And I've heard precious few 3 centimetre signals yet. But you know what I mean? It does seem to work okay, but you can turn your nose up at it. So, is it interesting? I don't know.
Well, thank you, Bernie. That you've certainly made up very good time. You've started a bit early, and we've made very good time. So there's certainly time for any questions.